Chapter 1. The Origins of Mechanical Vehicles. The history of the automobile begins long before the invention of the first modern car, at a time when most people only moved around on foot, on horseback, or on carriages. Even in ancient times, there were the first ideas of self-moving machines that were supposed to function independently of animal or human power. Greek and Roman sources contain reports of mechanical chariots and mobile devices that were moved by gears, springs, or weights. However, these constructions were mostly gimmicks or military experiments and had little influence on the mobility of the general population. The real technical basis for the automobile did not emerge until the invention of the steam engine in the 17th and 18th centuries. With the ability to perform mechanical work continuously and in a controlled manner, a completely new horizon for mobility opened up. Steam engines were initially used in industry, in mines, and on ships. Soon, however, engineers began to mount steam engines on wagons. In England, the first steam cars were created that could cover short distances on solid roads or special test tracks. They were heavy, loud, and unreliable, but they showed that it was possible to make transport independent of animals. At the same time, similar developments emerged in France, where engineers were also experimenting to transfer steam energy and motion on wheels. The steam cars posed new questions to society. How should roads be built so that these machines could run? Who was allowed to use the new technology and who controlled access to it? What social and economic changes would follow if machines could replace human and animal labor? Even then, engineers, entrepreneurs, and visionary thinkers recognized that mechanical locomotion would have not only technical but also social implications. Road construction, logistics, trade, and urban life were on the verge of profound upheavals, and the first steam cars provoked discussions about safety, noise, and order in the cities. In the second half of the 18th century, the designs of mechanical vehicles began to become more stable and efficient. Richard Trevithick in England built a steam carriage in 1801 that could drive on roads and transport loads. These vehicles were impractical for everyday use, but they showed the potential of the technology and inspired many inventors in Europe. At the same time, similar projects were developed in Germany, France, and the Netherlands. The vehicles were not yet suitable for large-scale passenger transport, but they laid the foundation for thinking in the direction of motorized individual mobility. In addition to technical developments, social and economic conditions were also decisive. The Industrial Revolution fundamentally changed work and production processes. Cities grew, factories produced in ever larger quantities, and the need for fast, reliable means of transport increased. Dealers, entrepreneurs, and politicians recognized the strategic importance of motorized vehicles for business and the military. During this time, a new kind of inventive spirit emerged. Technology was no longer just a science, but a means to meet social needs, conquer markets, and improve the quality of life. The steam cars also led to the establishment of the first traffic rules. Since vehicles were operated independently of horses and carriages, roads had to be adapted, speed controlled, and safety standards developed. In England, for example, special laws were passed to control steam cars on public roads, and the first test tracks were created on which engineers could test their vehicles. These regulations showed early on that the introduction of new technologies always requires social organization and legislation. In the same way, despite all the progress, steam cars still remained cumbersome and impractical. They were expensive, maintenance-intensive, and unsuitable for daily use. This made it necessary to search for alternate drives. The engineers of the time experimented with gas and gasoline engines to create lighter, more efficient, and more reliable vehicles. The idea of a car that worked without a steam boiler, without a constant supply of water, and without enormous heat sources came more and more to the fore. However, the early mechanical vehicles were not only technical marvels, but also symbols of an incipient industrial age. They represented progress, rationality, and man's ability to control and serve the forces of nature. For people at the time, the thought of self-driving cars was fascinating, futuristic, and sometimes frightening. Roads, cities, and rural regions had to adapt to this new form of transport, and the idea of speed, mobility, and personal freedom changed fundamentally. In this phase of early automotive history, the international dimension of technology also became apparent. Engineers in England, France, Germany, and the Netherlands experimented independently of each other, but exchanged ideas and concepts. Scientific publications, trade fairs, and technical societies served as platforms to present and further develop innovations. The development of mechanical vehicles was thus not only a local phenomenon, but a transnational process that laid the foundation for the later global automotive industry. At the same time, the first philosophical and social considerations about the automotive emerged. Technology was no longer understood only as a tool, but as a means to shape the way of life, the economy, and society. Questions about environmental pollution, social justice, public safety, and individual freedom were already present at that time. These debates show that from the very beginning, the car was more than a machine. It was a symbol of progress, power, and the ability of man to shape his environment. The origins of mechanical vehicles thus marked the first phase of automotive history, which paved the way for the invention of the internal combustion engine and the development of modern cars. Steam cars, experimental prototypes, and early gasoline experiments demonstrated that mobility was no longer tied to animal power. They opened up the possibility of a new era where people could travel more independently, faster, and more efficiently. At the same time, they laid the foundation for technical, social, and economic changes that would shape the 19th and 20th centuries. The fascination that these early vehicles sparked and the challenges they posed formed the starting point for the history of the car as we know it today. Chapter 2: The Creation of the Combustion Engine. Otto, Daimler, and Benz. The invention of the internal combustion engine marked a turning point in the history of the automobile, as it made motorized locomotion practical, efficient, and suitable for everyday use in the long term. While steam cars were still cumbersome, noisy, and cumbersome, the internal combustion engine opened up a new era of mobility that relied less on massive machinery and constant maintenance. The foundations for this were laid by a number of visionary engineers in the 19th century, whose work formed the foundation for the modern automotive industry. Nikolaus August Otto, a German inventor and inventor, is considered one of the central pioneers of this time. In 1876, he developed the four-stroke engine, which became known as the gasoline engine and formed the basis for the later internal combustion engines in cars. The gasoline engine worked on the principle of compressing air and fuel, which resulted in significantly higher efficiency compared to previous engines. This innovation made it possible to build smaller, lighter, and more powerful engines that could be installed directly in vehicles without the need for huge boilers or steam engines. Parallel to Otto, other engineers worked on the implementation of the engine in vehicles. Gottlieb Daimler, also German, pursued the goal of developing an engine that could be used universally and was not only suitable for stationary use or for ships, but also for road vehicles. Daimler experimented with gasoline as fuel, which was revolutionary for the time, because gasoline was readily available, relatively safe to store, and allowed for a compact engine design. Together with Wilhelm Maybach, he succeeded in developing the first practical motor car in 1885, which became known as the Daimler motor car. This car was small, maneuverable, and had a compact combustion engine which made the vehicle independent of horses or steam engines. At the same time, Carl Benz pursued similar approaches. In 1886, he received a patent for his Benz patent motor car, often referred to as the world's first true automobile. Benz's vehicle was not only technically mature, but also practical. It featured an internal combustion engine, simple controls, and a chassis specifically designed for propulsion with an engine. Benz understood that the combination of engine, chassis, and controls was crucial to creating a functioning car that was suitable for everyday use. The patent motor car marked the beginning of the age of individually motorized mobility, in which people were no longer dependent on horses or public transport.
However, the developments of Otto, Daimler, and Benz were not only technical achievements, but also an expression of far-reaching social change. Industrialization had changed production methods, and cities were growing rapidly. People were looking for new ways to move quickly and independently. Automotive technology addressed these needs directly and opened up new perspectives for trade, commuters, and private leisure activities. The idea of being able to cover greater distances in a short time fascinated people and triggered a surge in innovation that would massively accelerate car development in the coming decades. However, the introduction of the internal combustion engine also brought new challenges. The handling of gasoline was new and safety issues had to be clarified. Engines were loud, reliably functioning brakes had to be developed, and roads had to be adapted to the increasing traffic. Engineers and entrepreneurs were faced with the task of not only building vehicles, but also creating an infrastructure that made their operation possible. Petrol stations, workshops, and road planning were built step by step in parallel with the spread of the first vehicles, which influenced the development of society as a whole. The importance of Daimler, Benz, and Otto lay not only in the technical implementation, but also in the way in which they marketed and developed their inventions. They laid the foundations for companies that later became the major car manufacturers. Benz and C developed into a leading manufacturer. Daimler founded Daimler Motorengesellschaft, and Otto founded his own company, which produced engines for vehicles, ships, and machines. These companies combined technical innovation with industrial thinking, which was crucial for the later global success of the automotive industry. However, the early combustion engines were still very simple and inefficient by today's standards. They developed few horsepower, could only reach low speeds, and were maintenance intensive. Nevertheless, they represented a huge advance compared to steam cars, as they were compact, flexible, and efficient in use. They made it possible to build vehicles that were smaller, lighter, and suitable for individual use, making the car a symbol of freedom, engineering, and progress. The social impact was enormous. The first vehicles were initially luxury objects for the wealthy, but they aroused enthusiasm for new mobility among the population and led to initial discussions about traffic, road construction, and safety. In many European cities and in the USA, the first traffic rules were developed to regulate the operation of motorized vehicles. At the same time, automobiles began to change the image of the modern city. They enabled new forms of trade, leisure, and social exchange. People were able to visit places that were previously inaccessible and cover distances that would have previously required long journeys in a short time. From a technical point of view, Otto, Daimler, and Benz thus laid the foundation for the modern automobile. They showed that combustion engines could be powerful, compact, and universally applicable. Their developments inspired numerous engineers throughout Europe and the USA to build their own vehicles and further the technology. This phase was the beginning of continuous improvement. Engine performance, reliability, ride comfort, and design were constantly optimized over the coming decades. The work of Otto, Daimler, and Benz is also remarkable from an economic perspective. They demonstrated that technical progress must go hand in hand with entrepreneurial thinking. Patents, company structures, and production methods were developed that made it possible to transfer the new technologies to larger series production. This early combination of engineering skills and economic competence is a central factor in the later global success of the automotive industry and continues to shape it today. Finally, the introduction of the internal combustion engine led to a cultural transformation. Cars became symbols of status, freedom, and technological progress. They influenced art, literature, advertising, and later also film and music. The car was no longer just a means of transport, but an expression of a new lifestyle that focused on speed, independence, and mobility. The social fascination with the car began in this phase and it remains unbroken to this day. The developments of Otto, Daimler, and Benz thus marked the second major chapter in automotive history. They made the step from experimental steam cars to practical vehicles and prepared the basis for the mass production and worldwide distribution of the car. Without their innovations, the later developments from Henry Ford to the major European manufacturers to today's high-tech cars would have been unthinkable. They opened a new era of mobility that had not only technical but also economic, social, and cultural dimensions and laid the foundation for the modern automotive world.
Chapter 3: The First Road Vehicles. After the combustion engine had proven its functionality, a new phase in automotive history began: the development of the first road cars. These vehicles differed fundamentally from the experimental steam cars because they were smaller, lighter, more maneuverable, and, above all, practical for use on roads. The time between the invention of the gasoline engine and the widespread introduction of cars on public roads was characterized by a pioneering spirit, a love of experimentation, and technical challenges that had to be mastered in order to make the dream of individual mobility a reality. The first road vehicles that were built after 1886 were often simple designs. They consisted of a chassis, an engine, rudimentary controls, and wheels, which were usually taken over from carriages. The engineers had to find ways to mount the engine stably, ensure power transmission to the wheels, and at the same time develop a vehicle that could be steered without falling apart on small bumps. These vehicles were not yet production cars, but one-offs, often built to order. Each car was unique, and the owners not only had to understand the technology, but also have manual skills to carry out repairs. The speed of the first cars was modest, usually 10 to 20 kilometers per hour, but that was enough to test the road conditions in cities and in the countryside. At that time, roads were still primarily designed for horse-drawn carriages. Paved stones, gravel, and uneven paths posed great challenges for the early vehicles, and accidents were not uncommon. Many cities introduced special regulations to regulate the use of motorized vehicles. These include speed limits, mandatory warning signals such as bells or whistles, and rules for behavior towards horses and pedestrians. These measures show that the car was not only a technical but also a social challenge from the very beginning. The first cars were initially luxury objects for wealthy classes. They were bought by entrepreneurs, industrialists, and wealthy individuals who were interested in technology or were looking for status symbols. In Paris, London, Berlin, and other European metropolises, the first car clubs were formed, where enthusiasts met to exchange experiences, organize races, or discuss technical improvements. These clubs played an important role in popularizing the car because they made the public aware of the new means of transport and showed that it could be used in a practical and reliable way. The technical development in this phase was rapid. Engineers experimented with different engine sizes, power transmissions, and chassis types. Some vehicles had chain drives, others belt drives, and the engines became more and more powerful. The question of fuel was also the focus. Gasoline proved to be practical, but other engines were powered by spirit, gas, or oil. The diversity of approaches meant that automotive technology did not yet have standard solutions in the 1890s, and each manufacturer pursued its own concepts. Parallel to the technology, the road infrastructure also began to change. Cities adapted their streets for the new form of mobility by renewing pavements, widening paths, and introducing traffic signs. However, rural regions remained problematic, and early motorists often had to take long detours to get their vehicles to their destination undamaged. These infrastructure issues greatly influenced the design of the vehicles. Wheels, suspensions, and chassis had to be robust to survive bumpy roads, and engines had to run reliably even when road conditions were poor. An important aspect of the early road vehicles was their versatility. Some vehicles were used as vans, others as luxury cars for private individuals. The first ideas for public use, such as taxi-like services, emerged, and the idea that cars could be useful not only for technology enthusiasts but for the general population gained traction.
At the same time, the automotive industry began to establish itself as an economic factor. Workshops, suppliers, petrol stations, and dealers emerged, and it became clear that cars were not only technical objects but also products of a complex economic chain. The social impact of the first road vehicles was enormous. They changed people's relationship to space and time. Distances that previously required a day's journey could be covered in just a few hours. Cities became more accessible, rural regions became networked, and people's mobility increased drastically. The car increasingly became a symbol of freedom, independence, and technical progress. At the same time, the new vehicles led to conflicts. Horse-drawn carriages, pedestrians, and early cars collided regularly, and society had to learn to organize traffic. These conflicts show that technical innovations always require social adjustments. The design also played a role. The first cars were often designed like carriages, with an open body, steering wheel or control levers, and large wheels. They should not only function but also have a representative effect. The shape of the vehicles reflected the time. Elegance, luxury, and technical sophistication were central aspects. At the same time, functionality and reliability were crucial, and many vehicles have been continuously improved over the years to meet the increasing demands for speed, comfort, and safety. Another milestone was the organization of the first races and exhibitions. Competitions such as the Paris-Rouen Drive of 1894 demonstrated that cars could reliably cover longer distances. Such events not only had sporting significance, but also served as advertising and the further development of technology. Engineers were able to test new drives, test materials, and show the performance of their vehicles under real conditions. Racing contributed significantly to the popularization of the car and laid the foundation for a culture of the automobile that continues to this day. Finally, the standardization of components also began in this phase. While each vehicle was initially unique, manufacturers realized that recurring components reduced costs and simplified production. Engines, transmissions, wheels, and chassis were increasingly modular, paving the way for series production and the later cars which were mass-produced and made accessible to a wide audience. The early road vehicles thus laid the foundation for the automotive revolution of the 20th century. They proved that motorized locomotion could be practical, reliable, and economically viable. They changed cities, landscapes, and societies, opened up new economic opportunities, and shaped the idea of individual freedom and mobility. Without these first vehicles, the mass production, the spread of the car, and the cultural significance that the car would later achieve would have been unthinkable. The era of pioneer vehicles impressively shows how technical innovation, social change, and economic development can be intertwined. It laid the foundation for the automotive industry as we know it today, and made the car a central part of modern life. The fascination that these first vehicles generated, the challenges they brought, and the creativity that shaped their development form a decisive period in the history of mobility and mark the transition from the vision of motorized driving to reality on the roads.
Chapter 4: Series Production and Henry Ford. The development of the first road vehicles and the internal combustion engine was a significant technical advance, but for a long time it was limited to wealthy individuals. Vehicles were expensive, labor-intensive to produce, and only available in small numbers. It was only with the introduction of series production and the idea of producing cars in large quantities that the automotive became accessible to broad sections of the population. This change is closely linked to the name of Henry Ford, an American engineer and entrepreneur whose vision made the car not only a means of transport, but a mass product. Henry Ford was born in Michigan in 1863 and showed an early interest in technology and mechanics. After working in various workshops, he began to work on the design of his own vehicles. His vision differed from that of many of his contemporaries. He wanted to build not only a car for wealthy customers, but a vehicle for the masses. Ford realized that the availability of an affordable car was not just a matter of engineering, but more importantly, a matter of production efficiency. To achieve this goal, he had to revolutionize the entire manufacturing process.
In 1903, Henry Ford founded the Ford Motor Company. The first models were still comparatively expensive, but they laid the foundations for later expansion. Ford experimented intensively with manufacturing methods, materials, and work organization. He was looking for ways to drastically reduce the production time for a vehicle without compromising quality. In the process, he came up with a crucial idea: assembly line production. In automotive production at the time, each vehicle was largely assembled by hand. Each worker assembled many different parts, which took a lot of time and drove up production costs. Ford realized that breaking down work into specialized, repetitive tasks would greatly increase efficiency. In 1913, Ford turned its vision into reality and introduced the first moving assembly line in automotive production. The effect was revolutionary. The assembly time of a vehicle was reduced from more than 12 hours to less than 3 hours. At the same time, the price per car dropped significantly, making the car affordable for the middle class as well. The most famous model, the Model T, embodied this paradigm shift. It was simply designed, reliable, robust, and comparatively inexpensive. Ford also offered variants that could be adapted to different needs, thus laying the foundation for individualization in series production. The effects of series production were far-reaching. On the one hand, the number of vehicles on the roads increased rapidly. In just a few years, Ford was able to sell millions of vehicles, which fundamentally changed people's mobility. On the other hand, series production influenced the entire economy. Suppliers, workshops, and logistics companies benefited from the increasing demand for vehicle parts, tools, and services. New jobs were created, and the automotive industry developed into a central economic sector. Ford's approach revolutionized not only production but also the world of work. He introduced a higher wage level to attract skilled workers and avoid turnover. At the same time, he promoted strict work discipline, standardized processes, and increased efficiency. This model of industrial manufacturing, based on division of labor, assembly line, and quality control, was soon adopted by other industries and shaped modern industrial production worldwide. The social impact of mass production of cars was enormous. Suddenly, families and small businesses could afford vehicles that had previously been luxury goods. Mobility was democratized, which opened up new opportunities for living and working. People could live further away, commute to work, or take part in leisure activities at a greater distance. Cities expanded, suburbs emerged, and daily life changed fundamentally. The car became a symbol of freedom, progress, and social advancement. The design and technology of the vehicles also adapted to mass production. The Model T was deliberately kept simple to facilitate assembly and simplify repairs. The engine, chassis, and body were standardized so that spare parts could be replaced without any problems. The robustness of the vehicle made it suitable for the road conditions that were still poor at the time, especially in the countryside. Ford's philosophy showed that technical success, economic efficiency, and social impact are closely linked. The international impact was also significant. The example of Ford inspired car manufacturers in Europe, Japan, and other regions of the world to introduce similar manufacturing methods. The idea of producing cars in large quantities and making them affordable for broad sections of the population spread quickly. In Germany, France, and Great Britain, companies emerged that worked according to Ford's model, and Japanese industry later adopted these concepts. Ford's model of series production also had long-term cultural consequences. Cars became not only a means of transport, but an integral part of everyday life, lifestyle, and pop culture. Advertising, films, and literature began to portray the car as a symbol of adventure, freedom, and technological superiority. Roads, petrol stations, car parks, and workshops were created as infrastructure around the car. Cities were planned to accommodate the increasing traffic, and the social importance of the car increased continuously. Last but not least, mass production also changed consumer expectations. The idea that products could be affordable, reliable, and standardized set the standard for other industries. Electronics, household appliances, and mechanical engineering adopted similar production methods. The philosophy of efficiency, quality, and mass production became the central guiding principle of modern industrial society. Henry Ford's role in automotive history can hardly be overestimated. He combined technical understanding, organizational talent, and visionary thinking to create the foundation for the global automotive industry. With the introduction of mass production and the popularization of the Model T, the car no longer became a luxury item, but an everyday companion that changed people's lives forever. The phase of mass production thus marked a decisive turning point. From pioneer vehicle to mass mobile, from technical experiment to economic and social reality. It laid the foundation for the modern car industry, for the design of cities, for the economic development of entire countries, and for the cultural significance of the car, which continues to this day. Without Henry Ford's innovations and his vision of democratized mobility, the history of the automotive would have been very different.
Chapter 5. The expansion of the automotive industry in Europe. The development of the automobile in the United States by pioneers such as Henry Ford was only the beginning of a global revolution. Europe, which was already characterized by technical innovations in mechanical engineering and transport in the 19th century, reacted to the automotive innovation with enthusiasm and its own boost of creativity and entrepreneurial spirit. The European automotive industry developed rapidly in the first decades of the 20th century, with countries such as Germany, France, Italy, and the UK leading the way. Each region produced different approaches, designs, and manufacturing techniques that shaped the diversity and character of European vehicles. In France, the automotive industry was one of the first in Europe to make significant progress. As early as the 1880s, French engineers experimented with internal combustion engines, and cities like Paris became centers of innovation. Companies such as Peugeot and Renault began to produce vehicles that were suitable for both private and commercial use. Renault, for example, developed taxis and vans early on, while Peugeot focused on sporty and elegant vehicles. France was also a center for racing events, which not only promoted competition but also drove technical development. Racing through the French countryside tested engine performance, durability, and handling in real-world conditions, helping to make vehicles increasingly reliable and powerful. In Germany, the automotive industry initially emerged from a close interaction between engineering, mechanical engineering, and business. Carl Benz and Gottlieb Daimler are considered the founding fathers of the German automotive industry. Benz developed the first patented automobile in 1886, while Daimler worked with Wilhelm Maybach to improve engines and chassis. These early German vehicles were technically mature, robust, and suitable for the road conditions of the time. German industry was particularly strong in the production of precise machines and engines, which gave the cars a high technical quality. With the founding of companies such as Mercedes and Opel, systematic production began, initially in small series, later on a larger scale. Germany was characterized by a high degree of innovation, with engineers working intensively on engines, transmissions, and chassis to increase efficiency, speed, and comfort. Italy developed an automotive industry that was strongly focused on design and sportiness. Companies such as Fiat, Lancia, and Alfa Romeo emerged at the beginning of the 20th century and combined technical innovation with aesthetic standards. Italian vehicles were often lighter, more maneuverable, and suitable for road traffic in urban areas. In addition, racing played a central role in the development. Competitions such as the Targa Florio or the Mille Miglia served not only to entertain, but also to improve the vehicles in terms of engine performance, handling, and reliability. Italian cars embodied a mixture of technical sophistication and artistic design, which distinguished them from the more functionally oriented German vehicles. Great Britain also had an emerging automotive industry, which was strongly linked to mechanical engineering. British manufacturers such as Rolls-Royce, Bentley, and Austin developed vehicles that stood for luxury, stability, and reliability. Rolls-Royce in particular became internationally known for the precision of its engines and the quality of workmanship. British industry benefited from the colonial economy and access to raw materials necessary for vehicle construction, with an emphasis on durable, solid vehicles suitable for both urban transport and long-distance driving. The European expansion of the automotive industry was not limited to the production of vehicles, but also influenced the infrastructure and society.
Roads have been improved, bridges have been strengthened, and traffic regulations have been introduced to accommodate the new vehicles. Cities had to adapt. Parking spaces were planned, gas stations were built, and traffic signs were introduced. This was a profound change that prepared society for the motorized future. Increasing mobility led to economic opportunities. Companies were able to serve more distant markets, craftsmen and traders benefited from faster transport routes, and new services such as taxi companies or bus lines emerged. The European automotive industry benefited greatly from American developments, especially series production based on Henry Ford's model. European manufacturers adapted assembly line production and optimized it for their own markets. But there were also differences. While in the USA the focus was on mass mobility and low costs, many European manufacturers emphasized technical precision, design, and driving comfort. These differences reflected not only economic conditions, but also cultural preferences and infrastructure in the respective countries. Another driver of the European expansion was international competition. Racing events such as the Grand Prix in France, the Targa Florio in Italy, or hill climbs in Germany ensured that manufacturers developed ever more powerful, lighter, and more reliable vehicles. Racing served not only as advertising, but also as a laboratory for technological innovation. Improvements in engine performance, brakes, suspension, and aerodynamics were often first tested in racing cars and later transferred to production models. In addition, social acceptance played a decisive role. Initially, the car was a luxury object, but with increasing production and falling prices, it also became affordable for the middle class. People began to see cars not only as a means of transport, but also as a status symbol, leisure equipment, and a means of personal freedom. The growing number of vehicles changed the streetscape, the cityscape, and everyday life. The car's influence was omnipresent. It shaped architecture, urban planning, consumer behavior, and people's mobility habits. The European automotive industry thus developed in parallel with technical, economic, and social changes. It was an expression of engineering, economic dynamism, and cultural identity. Each country brought its own philosophy to the design, engineering, and production, creating a diverse and innovative environment. Germany focused on precision, Italy on design and sportiness, France on innovation and racing experience, Great Britain on luxury and stability. This diversity laid the foundation for the modern European automotive industry, which is still characterized by differences in style, technology, and market strategy. The expansion of the automotive in Europe shows how a technological innovation takes on international dimensions. It influences the economy, society, and culture, creates new branches of industry, changes the infrastructure, and has a lasting impact on people's everyday life. Europe developed into a center of vehicle innovation where technical knowledge, creative design, and industrial manufacturing merged. The European pioneers laid the foundation for the global automotive industry and showed that the car is much more than a technical device. It is a cultural phenomenon, an economic engine, and a symbol of progress, freedom, and mobility.
Chapter 6: Technical Innovations in Design in the Early 20th Century. The years following the introduction of series production were marked by rapid technical developments and design experiments. The car had evolved from a rare luxury item to an increasingly ubiquitous mode of transportation, and manufacturers began to combine technical innovation and aesthetic design. The early 20th century was a time of experimentation, competition for performance and reliability, and the search for a style of one's own. The industry was imbued with an atmosphere of progress, with engineers, designers, and entrepreneurs working together to make the car more efficient, comfortable, and attractive. One of the most important technical innovations of this era was the further development of the internal combustion engine. While early models often produced only a few horsepower, engineers developed more powerful and reliable engines that allowed for higher speeds and made longer journeys easier. Among other things, ignition systems, cooling systems, and fuel supply have been improved. The introduction of more robust transmissions and clutches allowed for smoother shifting and increased powertrain efficiency.
At the same time, chassis and suspension systems were improved to increase comfort on the roads, which were often still unpaved at the time. Shock absorbers, leaf springs, and the adaptation of the axles to different road conditions helped to make vehicles more stable, safer, and more pleasant to drive. In addition to technology, design increasingly came to the fore. Manufacturers began to view the body not only as a functional element, but as an expression of style, status, and identity. Vehicles were given different body shapes, from open-top roadsters to elegant sedans and practical commercial vehicles. Materials such as steel, aluminum, and wood were creatively combined, and the color scheme became more important. Italian designers experimented with curved lines and sporty proportions. French manufacturers focused on sophistication and elegance, while German models stood out above all for their precision and technical sophistication. The car was increasingly perceived as an art object that should be not only functional but also aesthetically pleasing. The early years of the 20th century were also marked by intense competition in racing. Races such as the Grand Prix, the Targa Florio, or the 24 Hours of Le Mans offered manufacturers the opportunity to test new technologies under extreme conditions. Engine power, aerodynamics, brakes, and chassis were constantly improved by the competition. Innovations developed on the racetrack quickly found their way into production vehicles. Thus, the races not only contributed to the popularization of the car, but also to the acceleration of technical advances. Racing became an engine for research and development, with speed, reliability, and engineering in direct competition. Another important field of innovation was the electrical system in the automobile. In the beginning, cars were mainly mechanically powered, but as early as the 1910s and 1920s, manufacturers were experimenting with electric starter systems, lighting systems, and the first electronic controls. These innovations made it much easier to handle the vehicle, made it more convenient to start, and improved safety. Lighting systems made it possible to drive at night, and electrical components gradually became an integral part of the vehicle. Safety also increasingly came into focus. Initially, there were hardly any standardized rules, and many early vehicles had no protective measures for occupants. With the increasing speed and the increasing number of vehicles on the roads, it became clear that accidents could have serious consequences. Manufacturers began to build more robust bodies, improve brakes, and make steering systems more precise. At the same time, initial considerations arose on traffic regulations, road safety, and driver behavior, which formed the basis for later standardization and regulation. Parallel to these technical innovations, the automotive industry also continued to develop economically. Many companies diversified their offerings, offering different models for different groups of buyers and experimenting with marketing strategies. Luxury vehicles were designed specifically for wealthy customers, while more affordable models were offered for the growing middle class. The differentiation according to price, performance, and features led to broader market acceptance and laid the foundation for today's product lines. The social impact of these developments was also noticeable. The car began to change daily life. People were able to travel greater distances, which led to new opportunities for work, leisure, and trade. Rural areas were better connected, cities expanded, and suburbs emerged. The car became not only a means of transportation, but also a symbol of freedom, mobility, and social advancement. The presence of the car shaped the cityscape. Streets were widened, parking areas were created, and traffic control systems were developed. In the 1920s and 30s, international cooperation and competition also began to intensify. European manufacturers were guided by American methods of series production but adapted them to local conditions. At the same time, international markets were opened up, vehicles were exported, and technical knowledge was exchanged. The automotive industry developed into a global network in which innovations and ideas were quickly disseminated. The early 20th century thus laid the foundation for the modern automotive industry. The combination of technical innovation, aesthetic design, economic efficiency, and social relevance had a lasting impact on the development. Vehicles became more powerful, comfortable, safer, and more stylish, while mass production facilitated their dissemination. Racing, competitions, and industrial innovations accelerated development and created a culture of continuous improvement. The early years of the automotive were thus a phase of intense dynamism in which technical, aesthetic, and economic factors merged. Engineers experimented with engines, chassis, and transmissions. Designers shaped bodies. Entrepreneurs optimized production processes, and society adapted to the new possibilities. This period shows that the car is much more than a means of transportation. It is an expression of technology, culture, style, and economic power. The development of technology and design in the early 20th century prepared the ground for further innovations that would increasingly make the car an indispensable part of everyday life in the course of the 20th century. The combination of efficiency, performance, and aesthetics, coupled with growing social acceptance, ensured that the car became not just a passing trend, but a lasting achievement of modern civilization.
Chapter 7. The Interwar Period: Economy, Politics, and Automotive Development. The years between the end of the First World War and the beginning of the Second World War were an eventful phase for the automotive industry, marked by political upheavals, economic challenges, and technological progress. After the war, many European countries were economically and infrastructurally weakened, but the need for mobility remained unbroken. The automotive, which had established itself as a technical marvel before the war, now had to adapt to the changed social and economic conditions. During this period, fundamental decisions were made that further established the car not only as a means of transport, but also as a symbol of social change and technological ambition. In Germany, the economic hardship after the war and the reparation payments imposed by the Treaty of Versailles led to an extremely tense economic environment. Nevertheless, the automotive industry remained active, driven by engineering skills and entrepreneurial spirit. Manufacturers such as Mercedes, BMW, and Opel worked to produce vehicles that were affordable for the middle class, but at the same time remained technically innovative. The focus was no longer solely on luxury and performance, but increasingly on everyday usability, reliability, and efficiency. At the same time, technical innovations such as improved engines, stronger brakes, and more stable chassis were pushed forward in order to meet the increased demands of consumers. During this time, Germany developed into a center of engineering, in which technical precision and economic necessity went hand in hand. France, which had suffered greatly during the First World War, was also faced with a difficult economic situation. However, French manufacturers such as Citroën and Peugeot took advantage of the need for innovation and adaptation to develop new vehicle concepts. Citroën relied on assembly line production based on the American model, while Peugeot relied on technical sophistication and design. France also continued to be the leader in racing, and the technologies and aerodynamic studies developed there were increasingly finding their way into production vehicles. Racing was not just advertising, but a laboratory for technical developments in which vehicles were tested, optimized, and perfected. Italy used the interwar period to make its automotive industry internationally visible through innovation and design. Fiat, Lancia, and Alfa Romeo developed vehicles that were technically reliable, but at the same time elegant and sporty. Italian manufacturers experimented with lightweight bodies, powerful engines, and modern suspension systems. Alfa Romeo, in particular, embraced racing as a means of technical improvement and branding, creating vehicles that excelled both on the road and on the track. Design became increasingly central, and vehicles were seen not only as a means of transport, but also as a status symbol and expression of style. Britain was characterized by a dual strategy during this period. Manufacturers such as Rolls-Royce and Bentley continued to focus on luxury and technical perfection, while companies such as Austin and Morris developed affordable vehicles for a wider range of buyers.
British industry combined technical reliability with a high level of comfort and stability. At the same time, exports were encouraged and British vehicles gained international recognition, especially in the colonies and the Commonwealth. The automotive industry thus became an important economic factor that created jobs, boosted exports, and disseminated technical knowledge. In the United States, series production according to Henry Ford's principles continued to prevail, and the availability of affordable vehicles revolutionized mobility behavior. Mass production made it possible to reduce costs, produce vehicles faster, and reach a broad section of the population. American models also influenced the European market, as European manufacturers adapted some techniques and production methods. American industry increasingly focused on comfort, design, and performance, with technical innovations such as more powerful engines, improved suspensions, and electrical components being introduced. The interwar period was also marked by an increasing social acceptance of the car. The vehicle was no longer used exclusively by the wealthy classes, but increasingly also by the middle and working classes. This led to a profound change in urban and rural life. People were able to travel greater distances, open up new residential areas, and use trade routes more efficiently. The car changed the infrastructure as roads were expanded, gas stations were built, and traffic regulations were introduced. Cities planned parking facilities and traffic management systems to accommodate the growing number of vehicles. Political factors also played an important role. In Germany, the National Socialist government influenced automotive development from the 1930s onward by launching projects such as the Volkswagen. The goal was to create an affordable car for broad sections of the population while strengthening industry for national purposes. The idea of a Volkswagen, which would be technically reliable, easy to maintain, and affordable, was revolutionary and laid the foundation for the later developments of mass mobility in Germany. Similar government interventions and subsidies have also taken place in other European countries, with a focus on economic stabilization, export promotion, and technological progress. Technical development in the interwar period included not only engines and chassis, but also the introduction of new materials and manufacturing techniques. Lighter metals, stronger alloys, and improved processing methods helped vehicles become stronger, more efficient, and more durable. Ergonomics also gained in importance. Seats, steering wheels, and controls were made more comfortable to make the driving experience more enjoyable. The combination of technology, design, and usability showed that the car was increasingly seen as an overall concept that combined performance, aesthetics, and functionality. Another key aspect was the growing influence of marketing and branding. Manufacturers began to sell their vehicles not only on the basis of technical advantages, but also on image, lifestyle, and prestige. Advertising, trade shows, and car shows became important tools for attracting customers, increasing brand awareness, and showcasing technical innovations. The car became a symbol of progress, freedom, and social status. Overall, the interwar period was an epoch of change in which technical innovations, social changes, and political conditions were closely intertwined. The car continued to evolve from a luxury good to a ubiquitous means of transport that gained economic, social, and cultural importance. The developments during this period laid the foundation for mass mobility after World War II and shaped automotive culture in Europe, the United States, and beyond. The combination of technical innovation, economic adaptation, social integration, and political influence made the interwar period a decisive phase in the history of the automotive. Vehicles became more powerful, comfortable, and affordable, while their presence permanently changed people's daily lives, urban infrastructure, and economic development. The automotive industry grew into a major economic factor that created jobs, disseminated technical knowledge, and laid the foundation for the global automotive culture of the 20th century.
Chapter 8: The Second World War and the Conversion of Automobile Production.
The outbreak of the Second World War in 1939 fundamentally changed the world, and thus also the automotive industry. In almost all warring nations, civilian production was severely curtailed or completely stopped, while industry was geared to the needs of war. Factories that had previously produced cars for the civilian market were converted into armaments factories. Engines, bodies, and production lines were now used to manufacture military vehicles such as armored cars, trucks, off-road vehicles, and ambulances. This phase presented the engineers and workers with enormous challenges, but at the same time also with opportunities to drive technical innovations under extreme conditions. In Germany, automobile production during the war was strongly geared to the needs of the Wehrmacht. Companies such as Volkswagen, Mercedes-Benz, and BMW now mainly produced off-road vehicles, trucks, and motorcycles for military purposes. The famous development of the KDF-Wagen, which later became known as the Volkswagen Beetle, was intended as a mass mobility project for the German population before the war, but was used almost exclusively for military applications during the war years. This change not only changed the production methods, but also the technical orientation of the vehicles. Robustness, off-road capability, and reliability under extreme conditions became central. In the United States, the automotive industry underwent a similar transformation, but with a clear focus on supporting the Allies. Henry Ford, General Motors, Chrysler, and other manufacturers switched their production to military vehicles. Tanks, transport vehicles, aircraft engines, and amphibious vehicles were produced in large quantities. The American automotive industry used its experience in mass production to respond quickly and efficiently to the demands of the war. This phase led to an intensive standardization of components, which later greatly simplified civilian vehicle production after the end of the war. Great Britain had already begun arms production before the outbreak of war and used the automotive industry specifically for military purposes. While companies like Rolls-Royce continued to develop high-performance engines for tanks and aircraft, Austin produced off-road vehicles and vans for the military. At the same time, new organizations and planning structures emerged to efficiently allocate resources, ration materials, and make optimal use of manufacturing capacity. This war production required innovations that were later transferred to civilian vehicles, such as the improvement of internal combustion engines, suspensions, and off-road capability. France and Italy saw their automotive production severely restricted by occupation and acts of war. In occupied territories, production was controlled, sometimes subordinated to the German war machine, while free companies had to reduce or adjust their production. In Italy, despite the difficult conditions, innovations continued to emerge, especially in the field of engine technology and vehicle design, which were later further developed in civilian vehicles after the war. One of the most notable developments during the war was the intensification of research in the field of off-road vehicles. Military requirements led to the development of all-wheel drive, improved suspension, stable bodies, and robust engines. Off-road capability, reliability under extreme conditions, and easy maintenance were paramount. These technological advances had a direct impact on the post-war period, when the need for robust, versatile vehicles grew in both the civil and commercial sectors. Off-road vehicles, such as the Jeep, which was developed in the USA during the war, became symbols of everyday use after the end of the war, as their versatility could be used for agriculture, transport, and leisure activities. The war years also led to an acceleration of innovation in the field of engine technology. Powerful engines for tanks, aircraft, and trucks required new materials, improved cooling, stronger cylinders, and more efficient fuel systems. After the end of the war, these technical advances flowed directly into civilian production. Vehicles of the post-war period benefited from the findings of military technology. Engines were more reliable, vehicles more robust, and ease of maintenance significantly improved. Another crucial aspect was logistics and manufacturing efficiency. War production required extremely efficient use of raw materials, precise planning, and fast production. Concepts such as assembly line production, modular design, and standardized components were perfected and formed the basis for the explosive development of automotive production in the 1950s. These structural improvements meant that after the end of the war, companies were able to produce large quantities of vehicles cost-effectively and open up new markets. The social impact of the war on the automotive world was also profound. During the war, private vehicles were severely restricted. Gasoline rationing and shortages of raw materials led to a temporary decline in civilian mobility. After the end of the war, however, the need for vehicles exploded as people wanted to regain their mobility. The reconstruction of roads, bridges, and urban infrastructure further increased this demand. Cars became a symbol of freedom, economic advancement, and new beginnings in the post-war period. Technical innovations from wartime production also influenced the design. Vehicles have been designed to be more robust, functional, and ergonomic. Off-road chassis, powerful engines, better brakes, and more stable bodies were now transferred to civilian vehicles. At the same time, manufacturers began to pay more attention to comfort, style, and design awareness in order to make vehicles more attractive to a wide range of buyers. The war years also led to a stronger internationalization of the automotive industry. Companies worked closely with governments, exported technology, adapted production methods from other countries, and developed standards that were later adopted globally. The networking of research, production, and logistics during the war laid the foundation for the global automotive industry as we know it today. Overall, the period of the Second World War shows how closely technology, politics, and society are connected. The automotive industry had to submit to the demands of military mobilization, but in the process it developed numerous innovations that revolutionized the civilian vehicles of the post-war period. The experience of war production, the optimization of manufacturing processes, the research of new materials, and the improvement of technical components led to the fact that the industry after 1945 started at a technologically and organizationally high level. The conversion of production during the war marked a decisive turning point. Vehicles were developed not only for efficiency and robustness, but also for versatility, ease of maintenance, and performance. These insights formed the basis for post-war automotive development. As the need for vehicles exploded, new markets were opened up, and the car became a central element of modern life.
Chapter 9: The Post-War Period and the Rise of Mass Mobility. With the end of the Second World War in 1945, a phase of reconstruction, modernization, and massive expansion of production began for the automotive industry. In Europe, many cities were in ruins, roads were destroyed, and economic resources were severely limited. Nevertheless, there was an unbroken urge for mobility. The car, which had largely served as a military instrument during the war, now became a symbol of reconstruction, progress, and personal freedom. During this period, the automotive industry underwent a fundamental transformation, both technologically and economically. In Germany, which was in ruins after the war, rebuilding automotive production was an immense challenge. Many factories were destroyed or occupied, raw materials were scarce, and the economic infrastructure was severely damaged. Nevertheless, companies such as Volkswagen, Mercedes-Benz, and BMW began to resume production. Volkswagen launched the Beetle, a vehicle that was originally planned as an affordable car for the general population before the war, but was now seen as a symbol of new beginnings and economic advancement. The Beetle was characterized by simple construction, reliability, and ease of maintenance, which quickly made it one of the best-selling vehicles worldwide. Mercedes-Benz, on the other hand, relied on luxury and technological innovations to maintain its position as the leading manufacturer of high-quality vehicles. BMW, facing production difficulties after the end of the war, focused on restoring engine and vehicle technology to serve both the domestic and international markets. In France, the focus was on the revival of manufacturers such as Citroën, Renault, and Peugeot. These companies used both their pre-war experience and the technologies gained during the war to create new vehicle models that were both affordable and reliable.
Citroën introduced innovative techniques, including suspension systems and aerodynamic bodies, which greatly improved driving comfort. Renault and Peugeot focused on the mass production of affordable vehicles that were particularly suitable for the emerging middle class. The French automotive industry thus became a central engine of economic reconstruction and contributed significantly to the stabilization of the economy after the war. Italy, which also suffered from the destruction of the war, used the post-war period to rebuild its own automotive industry. Fiat introduced models such as the Fiat 500, a small, affordable car that quickly became a symbol of urban mobility and economic advancement. Alfa Romeo and Lancia focused on sporty cars and technical innovations, which also gained international recognition. Italian manufacturers placed special emphasis on design and style, making the vehicles not only functional but also culturally relevant. In Great Britain, the post-war period was characterized by a balance between reconstruction and expansion. Manufacturers such as Austin, Morris, and Rolls-Royce played different roles. While Austin and Morris produced affordable vehicles for the general population, Rolls-Royce continued to focus on luxury and precision. The British government actively promoted the automotive industry through subsidies and export programs to both secure jobs and stabilize the economy as a whole. British industry also benefited from the technological advances made during the war, especially in the field of engine technology and materials research. In the United States, the war led to a massive acceleration of industrial capacities, which were now transferred to civilian production in the post-war period. The American automotive industry has been able to draw on existing production facilities, an experienced workforce, and technological advances to produce vehicles on an unprecedented scale. Models such as the Chevrolet Bel Air, the Ford Custom Line, or the Chrysler Windsor reflected the new American lifestyle: comfortable, powerful, and modern. The automotive industry was instrumental in the economic expansion of the United States, creating millions of jobs while driving the construction of a consumer society. A central aspect of this period was the rise of mass mobility. The car became increasingly affordable for broad sections of the population and changed from a luxury object to an everyday object. In many European countries and the USA, a new car culture emerged. Roads were expanded, petrol stations were built, garages were built, and urban transport systems were adapted. The car changed not only individual mobility, but also the social structure. People were able to reach more distant workplaces, better connect rural regions, and take advantage of new leisure opportunities. The concept of personal freedom became closely linked to automobility, and vehicles developed into symbols of independence and self-determination. Technologically, the post-war period was characterized by numerous innovations based on the advances of the war years. Engines became more powerful and efficient, bodies more stable and comfortable, chassis more robust. Vehicles have been increasingly optimized for everyday use, with a focus on safety, ease of use, and reliability. At the same time, the automotive industry began to pay more attention to aesthetic aspects. Design and style became central selling points, and vehicles became cultural icons that gained significance beyond their function. Another important factor was the globalization of the automotive industry. After the war, international markets were opened, exports were promoted, and technological cooperation was entered. Manufacturers used their experience and production capacities to offer vehicles worldwide. This international thinking not only contributed to economic stability, but also laid the foundation for the global spread of automotive technology and the emergence of global brands. The post-war period was also a phase of social transformation. The car changed the relationship between city and country, made commuting easier, and enabled the development of new suburbs. Cities have had to adjust traffic planning, road construction, and parking facilities to accommodate the growing number of vehicles. At the same time, automobility influenced leisure opportunities. Weekend trips, holiday trips, and access to recreational areas were massively facilitated by the car. Industrial production and social development went hand in hand, and the car became the engine of economic, social, and cultural change. Overall, the post-war period marked the transition from automotive necessity to automotive normality. Vehicles became affordable, reliable, and culturally significant. The technical advances from the war and the pre-war period were transferred to civilian production, and mass mobility led to a profound change in the economy, society, and infrastructure. The automotive industry established itself as one of the key economic factors driving innovation, employment, and social change. The reappraisal of wartime, the reconstruction, and the introduction of affordable vehicles laid the foundation for the explosive development of automotive culture in the 1950s and 1960s. In this phase, the car became not only a means of mobility, but also an expression of individuality, status, and lifestyle. The post-war period redefined automotive society, made the car ubiquitous, and set standards for production, design, and use that continue to have an impact.
Chapter 10. The 1950s, Consumer Society, Style, and Technology Boom. The 1950s marked one of the most formative periods in the history of the automobile, in which the vehicle was no longer just a means of transport, but became a symbol of lifestyle, prosperity, and cultural identity. After the deprivations of the war years, many countries, especially the USA and Western European countries, experienced an economic boom that gave rise to a consumer society in which cars played a central role. The automotive industry reacted to these social changes by not only focusing on technical improvements, but increasingly presenting vehicles as an expression of prestige, style, and progress. In the United States, cars of the 1950s reflected the optimism and spirit of optimism of the population. Manufacturers such as General Motors, Ford, and Chrysler developed vehicles that stood out with curved bodies, shiny chrome accents, and eye-catching colors. The Chevrolet Bel Air, the Cadillac Series 62, or the Ford Thunderbird stood not only for mobility, but also for status, modernity, and technological innovation. The design of the cars became a cultural statement, influenced by the American enthusiasm for space travel, futuristic architecture, and pop culture. At the same time, technological innovations such as automatic transmissions, power steering, brake boosters, and improved safety features were introduced, which significantly increased driving comfort and ease of use. In Europe, the development was somewhat different, as economic conditions stabilized more slowly after the war. Nevertheless, the car gained in importance here as an expression of individuality and social advancement. In Germany, the Volkswagen Beetle developed into a symbol of economic stability and mobility for broad sections of the population. With its reliability, ease of maintenance, and affordability, it decisively shaped the image of post-war automobility. In France, Citroën focused on practical, cost-effective vehicles with models such as the 2CV, which at the same time stood out for their innovative technology and clever design. Italian manufacturers such as Fiat, Alfa Romeo, and Lancia combined design and engineering to create vehicles that were both functional and aesthetically pleasing. Fiat, in particular, achieved massive success with the Fiat 500, as the vehicle was small, affordable, and ideal for urban mobility. The 1950s were also characterized by a strong expansion of the automotive markets. Road construction programs, new highway systems, and increasing urbanization led to a growing demand for vehicles. In the USA, the interstate highway system was introduced, which facilitated mobility over long distances and opened up new markets for cars. In Europe, road networks have been expanded and modernized to cope with increasing traffic. This infrastructure development not only contributed to economic expansion, but also changed the way people lived, worked, and spent their free time. Technologically, the automotive industry experienced a boom that built on the experiences of the war years and the post-war period. Engines became more powerful, more stable, and more efficient. Chassis and suspension systems have been further developed to increase comfort and improved driving safety.
Innovations such as self-supporting bodies, hydraulic brakes, and electric lighting systems set new standards. At the same time, safety aspects were increasingly taken into account, even if they did not have the significance they have today in the 1950s. Vehicles became more robust, durable, and reliable, meeting the demands of an increasingly mobile society. In addition to technical innovation and economic expansion, the social perception of the car also changed. The vehicle became a symbol of freedom, self-determination, and social status. Young people developed a special relationship with cars, which they used as an expression of independence and rebellion. Hot rods, custom cars, and tuned vehicles became a part of pop culture, influencing music, film, and fashion. In Europe, automobility was initially even more practical, but also gained emotional and symbolic significance, especially in the representation of quality of life and progress. Another decisive factor was advertising. The automotive industry began to sell vehicles not only on the basis of technical features, but also on lifestyle, emotions, and social status. Advertising campaigns showed cars in modern environments, combined with leisure, travel, glamour, and technology. This new form of marketing made a significant contribution to putting the car at the cultural center and generating desirability that went far beyond purely functional use. The 1950s were also marked by the internationalization of the automotive industry. American manufacturers expanded into Europe and Asia, while European companies began to offer their vehicles in international markets. Technology exchange, license production, and cooperation led to stronger networking in the industry. This paved the way for the global automotive industry as it would develop in the decades that followed. Another striking trend was the differentiation of vehicle classes. While small, low-cost vehicles such as the Fiat 500 or the Citroën 2CV appealed to the broad market, luxury and sports cars were aimed at wealthier buyers. Manufacturers such as Ferrari, Jaguar, and Mercedes-Benz relied on high-performance vehicles that combined technology, style, and exclusivity. This segmentation of the markets resulted in a wider range of products that covered different social classes and needs. The role of the car in leisure activities also increased in the 1950s. Road trips, weekend trips, camping trips, and trips to rural areas became popular. The car enabled new forms of mobility and leisure activities that were previously only possible to a limited extent. Restaurants, gas stations, motels, and parks adapted to these new needs, creating an automotive culture that permanently changed the economy, society, and everyday life. After all, the importance of the 1950s for automotive history can be explained not only by technology, design, or business, but above all by the fusion of functionality, style, and social relevance. The car became a central part of everyday life, a symbol of freedom and social advancement, and shaped the cultural identity of entire generations. This era laid the foundation for the explosive development of the automotive industry in the 1960s and for the emergence of a global car culture that can still be felt today.
Chapter 11: The 1960s, Design Revolution and Mass Culture. The 1960s marked a turning point in the history of the automobile, marked by innovation, social change, and an increasing integration of the car into pop culture. In this decade, technology, design, and lifestyle merged to an unprecedented degree, making the vehicle a symbol of youth, freedom, and progress. The automotive industry responded to the growing level of prosperity and changes in society by launching new types of vehicles, modern designs, and technological innovations. In the United States, the Big Three, General Motors, Ford, and Chrysler, dominated the market in the early 1960s. Vehicles became larger, more comfortable, and more stylistically striking. The introduction of muscle cars such as the Ford Mustang, Chevrolet Camaro, or Pontiac GTO reflected the desire for power, speed, and youthful dynamism. These vehicles embodied an attitude to life that was strongly influenced by the emerging youth culture, rock and roll, and the pursuit of individuality. They were not only a means of transport, but an expression of personality, a thirst for adventure, and social belonging.
At the same time, competition between manufacturers led to a rapid surge in innovation. Engine technology, chassis, brakes, and safety equipment have been constantly improved to increase performance, reliability, and ride comfort. In Europe, the development in the 1960s was more differentiated, as the market was more fragmented and the economic differences between countries became more apparent. In Germany, Volkswagen developed into a symbol of mobility for broad sections of the population. The Beetle continued to be produced in large numbers, while Mercedes-Benz and BMW produced vehicles for the upscale segment that combined technology, luxury, and prestige. France focused on innovation and design. Citroën introduced models such as the DS, which caused a sensation with their futuristic design, hydropneumatic suspension, and technical sophistication. Italian manufacturers such as Fiat, Alfa Romeo, Lancia, and Ferrari used design, sportiness, and technological creativity to create vehicles that gained international recognition and were considered symbols of the Italian way of life. The 1960s were also marked by international expansion and cooperation within the automotive industry. European manufacturers increasingly sought access to American markets, while American companies expanded into Europe and Asia. Licensed production, joint ventures, and technological collaborations led to a stronger networking of the industry and laid the foundation for the globalized automotive industry, which was to develop in the decades that followed. Design played a central role in the 1960s. Vehicles were no longer developed solely according to functional criteria, but were also regarded as aesthetic objects. Flowing lines, futuristic shapes, eye-catching chrome accents, and colorful paintwork dominated the appearance of the vehicles. Designers became central designers of the brand and shaped the image of the manufacturers. The car was increasingly perceived as a lifestyle object that expressed status, personality, and cultural affiliation. In Europe, this was particularly evident in sports and luxury cars, while in the USA, muscle cars and convertibles determined the popularity of the vehicles. Another formative factor was the increasing integration of the car into pop culture. Films, music, and advertising staged vehicles as part of a modern lifestyle. Young people identified with certain models. They became symbols of rebellion, adventurousness, and independence. The car became more than just a means of transport. It became a cultural phenomenon, an emotional link, and an expression of individual identity. Road trips, excursions into the countryside, and life in suburbs were closely linked to owning and using one's own car. Technologically, the 1960s were marked by considerable progress. Engine performance and efficiency increased continuously, while safety aspects were given greater consideration for the first time. Disc brakes, seat belts, and more stable bodies were introduced to meet the increasing demands for speed, comfort, and safety. At the same time, research into alternative propulsion systems and fuel technologies began, but these would only become more important in later decades. In the cities and in the countryside, the growing number of vehicles changed the infrastructure considerably. Road networks have been expanded, parking areas have been expanded, and petrol stations have been modernized. Automobility influenced urban life, settlement structures, and leisure activities. Suburbs were built, shopping malls were built, and social dynamics changed. The car made it possible to travel greater distances between home, work, and leisure activities, which gave a new significance to the mobility of the population. This decade also saw a growing awareness of the impact of automobility on the environment and society. Initial discussions about traffic congestion, noise, and air pollution began, albeit still on a limited scale. These topics would not receive greater attention until the 1970s, but the 1960s laid the foundation for a critical examination of the consequences of mass car ownership. The 1960s also marked the beginning of the segmentation of the automotive market into different target groups. Family cars, sports cars, city cars, luxury vehicles, and commercial vehicles have been specifically developed to serve the needs of different groups of buyers. Manufacturers recognized that not only technical quality, but image, design, and lifestyle were decisive for market success. This development led to a wide range of products that appealed to both the mass market and exclusive buyers. In conclusion, it can be said that the 1960s shaped automotive history in several respects. Technology, design, society, and culture merged to form a new understanding of automobility. The car became not only a means of transport, but an expression of style, individuality, and social belonging. The developments of this decade lay at the foundation for modern car culture, mass mobility, and the global importance of the automotive industry. Vehicles became icons of an era marked by optimism, belief in progress, and cultural transformation. And they left a lasting impact on the economy, society, and lifestyle.
Chapter 12: The 1970s: Oil Crises, Environmental Awareness, and Technological Adaptation. The 1970s represented an era of upheaval, crisis management, and technological adaptation for the automotive industry. After the economically prosperous 1960s, the industry was confronted with completely new challenges that were both global and social in origin. The oil crises of 1973 and 1979 led to massive price shocks in the energy markets, which directly affected the automotive sector and changed the entire way cars were produced, used, and perceived. Vehicles that had previously been defined by performance, size, and luxury now had to prioritize efficiency, fuel economy, and economy. These changes not only presented engineers and designers with new tasks, but also influenced purchasing decisions, market strategies, and society's attitude towards mobility. In the United States, the effects of the oil crisis were felt particularly strongly, as American cars of the previous decade were predominantly large, heavy, and fuel-intensive. Models such as the sedans of General Motors, Chrysler, and Ford, which had been successful in the 1960s due to size, comfort, and prestige, suddenly came under pressure. Consumers are looking for smaller, lighter, and more efficient alternatives. Japanese manufacturers such as Toyota, Honda, and Nissan took advantage of this gap in the market and increasingly pushed into the American market. Vehicles such as the Toyota Corolla or the Honda Civic offered a combination of reliability, economical consumption, and affordable price that opened up new perspectives for American customers and changed the market in the long term. In Europe, the oil crises accelerated the already ongoing development towards smaller, more economical cars. Countries such as Germany, France, and Italy relied on compact models designed for urban transport, daily commuting, and the more efficient use of resources. The Volkswagen Golf, the Fiat 127, and the Renault 5 became symbols of a new automotive rationality that put performance and prestige behind practical utility and energy efficiency. At the same time, this period led to a greater awareness of environmental issues. Air pollution, noise, and traffic density moved into the public consciousness. Governments began to introduce regulations on emissions and safety standards, forcing manufacturers to develop innovative solutions to meet the new requirements. Technologically, the 1970s were marked by profound change. The automotive industry had to react to the new economic and ecological conditions and began to make engines more efficient, reduce weight, and use alternative materials. The development of catalytic converters, exhaust gas purification systems, and economical carburetors were among the decisive innovations of this decade. Chassis and safety development also made progress. Anti-lock braking systems, reinforced body structures, and improved seat belts were introduced to increase both the comfort and safety of the vehicles. These technological adaptations marked the beginning of a new era in which environmental responsibility and engineering skills increasingly merged. In terms of design, the appearance of the vehicles changed. The long, elongated lines and lavish chrome applications that dominated until the 1960s were replaced by more compact, functional, and aerodynamically optimized shapes. Vehicle aesthetics were increasingly shaped by practical considerations such as fuel efficiency, ease of maintenance, and interior optimization. At the same time, the individualization of cars continued, and designers found ways to add character and appeal to smaller and more economical models. Japanese and European small cars in particular used innovative space concepts to offer comfort and practicality despite small dimensions. A decisive aspect of the 1970s was the growing importance of global markets and international competition. The oil crisis showed how much the automotive industry depends on geopolitical and economic factors. Manufacturers began to develop global strategies to be able to react flexibly to crises. Collaborations, joint ventures, and international production facilities became more important in order to reduce dependence on individual markets or resources. At the same time, there was a stronger exchange of technologies and know-how between the countries, which formed the basis for the globalized automotive industry of the coming decades. The 1970s also changed the relationship between cars and society. Vehicles were no longer perceived only as a symbol of status, freedom, or prestige, but increasingly as an instrument of practical mobility that had to be used economically, ecologically, and socially responsibly. Awareness of the consequences of massive automobility grew. Traffic congestion, environmental pollution, and rising energy costs led to critical reflection on the benefits, significance, and design of vehicles. Car manufacturers, politicians, and consumers began to redefine the balance between technology, comfort, efficiency, and social responsibility. In this decade, the development of alternative drive technologies also began, albeit initially only in rudimentary form. Electric vehicles, hybrid concepts, and more fuel-efficient combustion engines were seriously researched for the first time, with most of these projects resulting in experimental models and limited series products. The challenges of the oil crises and environmental policy accelerated this research and laid the foundation for later technological developments that were to be central in the 21st century. In addition to technical and economic developments, the culture of the 1970s also had a strong influence on the automotive. Environmental movements, political protests, and social upheavals led to a new awareness of sustainability and responsibility. Cars were increasingly included in discussions about quality of life, urbanization, and resource consumption. At the same time, they continued to be an expression of personal freedom, individuality, and lifestyle, albeit now under changed conditions. The balance between the desire for mobility and the need to take ecological and economic constraints shaped the entire decade. In summary, the 1970s were a period of adaptation, crisis management, and technological innovation. The oil crises, growing environmental awareness, and economic constraints led to a fundamental rethink in the automotive industry. Efficiency, technology, and sustainability became more important, while prestige and status were only dominant to a limited extent. At the same time, these years laid the foundation for the global, technologically oriented, and environmentally conscious automotive world of the coming decades. Vehicles became more geared to the real needs of society, and the industry began to set the course for innovations that went far beyond pure vehicle construction. Chapter 13: The 1980s, Technologization, Security, and Globalization. The 1980s were a phase of consolidation, technological progress, and increasing globalization of the automotive industry. After the economically and ecologically turbulent 1970s, the industry began to develop strategies that combined efficiency, safety, and comfort as well as international market presence. This decade was characterized by a strong integration of new technologies, a growing awareness of safety standards, and an increasing networking of markets, manufacturers, and consumers. In the United States, the trend towards smaller and more efficient vehicles, which had been triggered by the oil crises of the 1970s, continued. At the same time, the American auto industry began to implement modern electronic systems.
Fuel injection systems increasingly replaced carburetors. Onboard computers began to optimize engine operation and fuel economy, and electronic ignition systems increased the reliability and performance of vehicles. Despite these technological advances, American industry continued to struggle with competition from Japan, which dominated the market with efficient, reliable, and low-cost vehicles. Manufacturers such as Toyota, Honda, and Nissan established themselves sustainably in the USA and had a considerable influence on the development of domestic models. In Europe, the focus was primarily on safety and quality. The 1980s brought a significant improvement in vehicle safety with the introduction of seatbelts, impact zones, and reinforced body structures. Vehicle tests and crash studies gained in importance, and manufacturers began to market safety as a key sales factor. Germany continued to focus on a mix of luxury, technology, and reliability, while Italy, France, and the UK presented innovative models in both the compact and sports car segments. Japanese manufacturers also gained traction in the European market, offering vehicles with modern technology and high efficiency that met the needs of an increasingly environmentally conscious and cost-conscious group of buyers. The 1980s were also the decade of technologization. Vehicles were equipped with increasingly complex electronics. Onboard computers, digital displays, and electronic controls not only facilitated operation, but also improved maintenance, efficiency, and driving comfort. Automatic transmissions were further developed, electronic injection systems became established, and comfort features such as power windows, air conditioning, and central locking systems were increasingly standardized. This technological integration fundamentally changed the relationship between driver and vehicle. The car was perceived not only as a means of transport, but as a technical system whose operation, maintenance, and optimization increasingly required expertise. Parallel to these technical developments, the design of the vehicles changed again. In the 1980s, aerodynamics became more important, resulting in flatter, smoother, and often more angular bodies. Vehicles became more efficient, more economical, and at the same time more visually modern. Japanese and German manufacturers in particular used aerodynamic optimization to reduce fuel consumption while increasing performance and ride comfort. Design was no longer determined solely by aesthetic considerations, but increasingly by technical requirements and energy efficiency, without the vehicles losing any of their visual appeal. A central aspect of the 1980s was the globalization of the automotive industry. Manufacturers increasingly operated internationally, produced in several countries, and exported models worldwide. Joint ventures, cooperations, and international production lines enabled companies to react flexibly to changes in demand, reduce costs, and open up markets in a targeted manner. This globalization also led to increased competition, accelerated the exchange of technologies and design ideas, and increased the pressure to market faster. Markets in North America, Europe, and Asia moved closer together, and the automotive industry began to see itself increasingly as a globally networked sector. The 1980s were also marked by social change that influenced the function of the car. Environmental awareness, safety requirements, and rising fuel prices have led to a differentiated perception of mobility. The car was not only seen as a status symbol, but increasingly as a tool for responsible, economical, and safe mobility. At the same time, cars remained an expression of lifestyle and individuality. Sports cars, sedans, and innovative models were deliberately marketed as status objects, with image, design, and technological sophistication in the foreground. The sports and luxury vehicle industry experienced a heyday in the 1980s. Ferrari, Porsche, Lamborghini, Maserati, and other manufacturers presented powerful, technologically advanced models that set standards both on the road and on the track. At the same time, sporty small and medium-sized cars became popular because they combined driving pleasure, efficiency, and affordable prices. Four-wheel drive vehicles and off-road vehicles also gained in importance, especially in North America, where leisure, outdoor activities, and adventure were increasingly shaped by automotive mobility. The 1980s also led to greater regulation and standardization. Safety regulations, emission limits, and fuel consumption standards limit manufacturers' creativity, but at the same time encourage technological innovation. Catalytic converters, exhaust gas purification systems, and energy-efficient drive concepts have been further developed, and vehicles have been increasingly designed to be more environmentally friendly. This was an important step towards a more responsible use of resources and the long-term adaptation of the industry to global challenges. In conclusion, the 1980s were a decade of transformation, consolidation, and technological modernization. The combination of technological innovation, growing environmental and safety awareness, as well as global networking fundamentally changed the automotive industry. Vehicles became more powerful, safer, and more efficient, while at the same time reflecting the individual lifestyles of their users. These developments laid the foundation for the modern automotive world in which technology, sustainability, comfort, and global market strategies are inextricably linked. The 1980s showed how dynamically the industry could react to economic, social, and technological challenges and paved the way for the comprehensive changes of the coming decades.
Chapter 14. The 1990s. Digitalization, Environmental Awareness, and New Mobility Concepts. The 1990s represented a transformative phase in the history of the automotive industry, marked by increasing digitalization, increased environmental awareness, and the development of new mobility concepts. After the 1980s had already driven technological advances and globalization, the industry began to systematically expand these approaches in the 1990s and combine them with an increasing sensitivity to environmental and social factors. Vehicles became highly complex systems that not only fulfilled pure transport, but also combined safety, efficiency, comfort, and environmental compatibility at the same time. Digitalization fundamentally changed the automotive industry. Vehicles were equipped with computerized controls that optimized engine performance, braking, fuel consumption, and comfort systems. Onboard computers began to integrate sensors, diagnostic instruments, and electronic control units, making maintenance and repair easier and more precise. The introduction of electronic injection systems, ABS braking systems, and airbags led to a significant increase in safety and reliability. At the same time, the electronic networking of vehicles opened up possibilities for innovative driver assistance systems that were intended to make road traffic safer and more efficient. In the 1990s, environmental awareness increased sharply. Climate change and increasing pollution from pollutants are increasingly becoming the focus of public discussion. Governments and international organizations enacted stricter emission standards and fuel economy regulations. Manufacturers responded by developing more efficient engines, lighter bodies, and alternative drive technologies. Electric vehicles and hybrid cars have not yet been produced on a large scale, but the first production-ready models were presented, and numerous prototypes demonstrated the potential of these technologies. The automotive industry began to incorporate environmental responsibility more strongly into its strategies and to plan for the long-term sustainability of vehicles. In terms of design, the trend towards aerodynamic, compact, and at the same time comfortable vehicles continued. Vehicles have been lighter, more rationalized, and functionally optimized overall. At the same time, comfort and lifestyle gained in importance. Ergonomically designed interiors, improved seats, sophisticated lighting systems, and modernized dashboards shaped the appearance of the vehicles. Especially in Europe and Japan, vehicles were increasingly designed in such a way that they both met aesthetic requirements and could be used practically and efficiently in everyday life. In the USA, the trend towards large SUVs, off-road vehicles, and pickups remained, the popularity of which was promoted in particular by the desire for leisure mobility, safety, and robustness. The 1990s were also marked by accelerated globalization. Manufacturers expanded their production sites, cooperated internationally, and adapted their models to different markets. This globalization has led to more intense competition and, at the same time, to a faster spread of innovations.
Asian manufacturers such as Toyota, Honda, and Nissan consolidated their market positions in Europe and North America, while German manufacturers such as Volkswagen, BMW, and Mercedes-Benz focused on quality, luxury, and technical sophistication. Cooperation between international markets, the standardization of production processes, and the introduction of global quality controls became decisive factors for success in this decade. Security issues were given new priority in the 1990s. Airbags became standard in many vehicles, ABS braking systems, and electronic stability controls were further developed and introduced across the board. Road safety research, crash tests, and the implementation of child safety systems made cars safer than ever before. At the same time, the idea prevailed that vehicle design should not only be functional and aesthetic, but also preventive with regard to accident risks. The automotive industry began to take a holistic view of vehicles, in which handling, design, safety features, and driver assistance systems were integrated and coordinated. New mobility concepts came to the fore. The 1990s showed the first beginnings of a more comprehensive transport planning, in which cars were no longer considered in isolation, but as part of a larger, sustainable transport network. Car-sharing models, which were introduced experimentally in Europe and North America, as well as the discussion about urban transport planning and multimodality, laid the foundation for later developments in the field of sustainable mobility. The idea that vehicles must be integrated into existing transport systems in a more efficient, flexible, and ecologically compatible way gained social relevance. Technological integration has also led to the emergence of a new type of driving experience. Navigation systems based on satellite technology were implemented in the first models and improved both orientation and travel planning. Electronic comfort systems such as automatic climate control, central locking, and electric seats became increasingly standard, making the car a multifunctional, intelligent living space. These developments showed that digitalization could revolutionize not only efficiency, but also convenience, security, and ease of use. The performance and sports vehicle industry also benefited from technological advances. Vehicles such as the Ferrari F50, the McLaren F1, or the Porsche 911 Turbo presented both extreme performance and precision technology. At the same time, there was an increasing link between technology, luxury, and everyday practicality in upper mid-range vehicles that combined comfort, efficiency, and innovation. Sportiness was no longer limited to high-performance sports cars, but was increasingly translated into everyday usability, handling, and technological sophistication. Finally, the 1990s were also marked by a change in the consumer perspective. Buyers expect vehicles to deliver not only performance and design, but also efficiency, environmental compatibility, safety, and technological innovation. Car manufacturers had to react flexibly to these new requirements and develop models that were economically as well as ecologically and technologically convincing. This led to a paradigm shift in the industry, with sustainability, innovation, and global market strategies increasingly intertwined. In summary, the 1990s can be described as a decade of digitalization, environmental awareness, and the conception of new mobility approaches. Vehicles became complex systems that combined technology, safety, efficiency, and comfort. Globalization and technological networking had a lasting impact on the industry, while at the same time, ecological and social responsibility came to the fore. The developments of this decade laid the foundation for the automotive world of the 21st century, in which digital systems, sustainable drives, and innovative mobility concepts play central roles. The 1990s proved that the automotive industry could not only respond to technological innovation, but also shape it itself to meet the demands of an increasingly complex, globalized, and ecologically sensitive society.
Chapter 15: The 2000s, Electronics, Globalization, and Alternative Drives. The 2000s marked a turning point in the history of the automotive industry. While the past decades were characterized by mechanization, safety, and the beginning of digitization, this decade brought a comprehensive integration of electronics, deeper globalization, and the first serious efforts to find alternative drives. The automobile increasingly changed from a pure means of transport to a complex, electronically controlled system that operated in global markets and at the same time had to meet the requirements for efficiency and sustainability. At the beginning of the new millennium, electronics and onboard computers were the main focus of vehicle development. Vehicles were increasingly equipped with integrated control units that not only monitor the engine and transmission, but also controlled the brakes, driving stability, comfort systems, and consumer electronics. The ABS system, already widely used before, was supplemented by electronic stability programs, ESP, which actively worked against skidding and skidding of vehicles. Engine controls optimized performance and consumption in real time, and sensors monitored a wide range of vehicle parameters, from tire pressure to environmental conditions. This turned the car into a highly integrated electronic system whose safety, efficiency, and comfort could be improved through continuous software updates. Parallel to electronization, the globalization of the automotive industry continued. International cooperations, mergers, and joint ventures determined the image of the industry. European, American, and Asian manufacturers set up production facilities around the world to optimize logistics, serve local markets directly, and benefit from cost advantages. Production standards were standardized internationally. Quality controls were adapted globally, and the networking of supply chains took on an unprecedented scale. This globalization made the industry more flexible, but at the same time more sensitive to economic fluctuations and geopolitical events. One example of this was the increased competition between Asian and Western manufacturers who were fighting for the favor of consumers both technologically and in terms of price. Another central issue in the 2000s was the environmental compatibility of vehicles. With rising gasoline prices, increasing urban air pollution, and growing global discussions about climate change and CO2 emissions, manufacturers have been forced to develop concepts for more efficient and cleaner vehicles. Hybrid drives, which combined combustion engines and electric motors, entered the mass market for the first time, especially the Toyota Prius, which was considered a symbol of environmentally friendly mobility. At the same time, low-emission diesel engines became popular in Europe, while strict emission standards such as Euro 3 and Euro 4 are forcing the development of cleaner engines. The 2000s thus marked the transition from purely performance-oriented vehicles to environmentally conscious vehicles, a paradigm shift that was to have a lasting impact on the entire industry. In terms of design, the decade shaped both aesthetics and functionality. Vehicles became more aerodynamic, lighter, and more energy efficient without neglecting comfort or safety standards. Material innovations such as high-strength steel, aluminum, and, for the first time, large-scale plastics improved both safety and fuel efficiency. At the same time, the individualization of vehicles gained in importance. Customers expected flexible options, from color design and interior design to high-tech features such as GPS, navigation systems, onboard entertainment, and networked communication systems. The car was increasingly marketed as a lifestyle product that functionally combined comfort, safety, and status symbol in addition to mobility. An important aspect of the 2000s was the increasing integration of driver assistance systems. Cruise control was electronically optimized, adaptive cruise control came onto the market, parking sensors and reversing cameras made maneuvering easier, and the first adaptive lighting systems improved visibility and safety when driving at night. These systems paved the way for later developments towards semi-autonomous driving and fundamentally changed the interaction between driver and vehicle. Vehicles were not only seen as mechanical means of transport, but as intelligent systems that actively contributed to safety and comfort. The sports and luxury vehicle industry also benefited from electronics and material development during this decade.
Manufacturers such as Ferrari, Porsche, Lamborghini, and BMW combined powerful engines with electronic stabilization systems, aerodynamic bodies, and high-tech interiors. At the same time, the SUV sector gained popularity. Vehicles such as the BMW X5, Mercedes M-Class, and the Toyota RAV4 set new standards in terms of comfort, all-wheel drive capability, and lifestyle. SUVs increasingly became a symbol of urban mobility, safety, and adventure, which in turn diversified the market offering and drew consumer interest to new vehicle segments. Globalization was also reflected in brand diversity and consumer behavior. Asian manufacturers consolidated their market position, European brands expanded into new regions, and American manufacturers responded to international competition by placing greater emphasis on efficiency, quality, and innovation. Global models have been adapted for different markets, and production strategies have been optimized to meet global demand as flexibly as possible. At the same time, this led to more intense competition, which accelerated innovation, but also put economic pressure on companies that could not keep up with technological developments. Another characteristic of the 2000s was the development of alternative mobility concepts. Car-sharing models and the first approaches to electric cars emerged, especially in urban regions. Manufacturers and cities experimented with concepts that would relieve urban traffic, reduce energy consumption, and promote environmentally friendly mobility. These ideas, which were still experimental at the beginning of the decade, laid the foundation for later developments in the direction of electric mobility, connected vehicles, and intelligent transport systems. In conclusion, the 2000s were a decade of transformation, innovation, and setting the course. The electronics, globalization, and the move toward alternative drive systems fundamentally changed the car. Vehicles became complex systems that combined not only mobility, but also safety, comfort, environmental friendliness, and lifestyle. The developments of this decade had a lasting impact on the direction of the automotive industry, laid the foundation for modern powertrains, intelligent vehicles, and connected mobility, and showed that technological innovation, global strategies, and environmental responsibility would be inextricably linked in the future.
Chapter 16, the 2010s, Electric Mobility, Autonomous Driving, and Connected Vehicles. The 2010s represented a profound upheaval in automotive history, more influenced by technological, environmental, and digital factors than any previous decade. While the 2000s had laid the foundation for electronics, alternative powertrains, and globalization, the 2010s decade consistently continued these developments, bringing vehicles into a new era of connectivity, autonomy, and sustainability. These years were marked not only by innovation, but also by fundamental changes in the perception of the car as a product, status symbol, and mobility solution. A central topic of the 2010s was electromobility. While hybrid vehicles were already established in the 2000s, pure electric vehicles were now ready for series production and began to seriously change the automotive market. Manufacturers like Tesla revolutionized the industry by presenting powerful, everyday, and technologically advanced electric cars that were not only emission-free, but also fast, comfortable, and intelligently connected. Traditional manufacturers such as Nissan, BMW, Chevrolet, and Volkswagen reacted to these developments, investing massively in research and production of electric vehicles and developing their own platforms for battery electric models. Battery technology, charging infrastructure, and energy management became central factors that determined the market success of vehicles. At the same time, public awareness of climate change, emissions, and sustainable mobility rose sharply, so that electric cars no longer just technological experiments, but socially relevant alternatives to the combustion engine. In addition to electromobility, autonomous driving has become increasingly important. The first advanced driver assistance systems developed into semi-autonomous systems that relieved the driver in certain situations, such as when parking, in traffic jams, or on the highway.
Car manufacturers invested heavily in sensor technology, camera systems, radar and LiDAR technologies to develop vehicles that could not only be safer, but increasingly also act independently. In parallel, a race arose between established manufacturers and technology companies such as Google, which tested autonomous vehicles and pushed the boundaries of what was possible in practice. Discussions on ethical issues, liability, data security, and regulation accompanied these developments intensively, as autonomous vehicles had not only technical but also social implications. Connected vehicles were another defining feature of the 2010s. Vehicles are increasingly becoming hubs in a digital ecosystem. Onboard infotainment systems, smartphone integration, real-time traffic data, and vehicle-to-vehicle communication changed the way people use their vehicles. The car was no longer just a means of transportation, but also a connected space that collected, shared, and processed information. This connectivity led to new opportunities for intelligent traffic control, preventative maintenance, safety monitoring, and personalized driving experiences. At the same time, new business models emerged, including car-sharing platforms, subscription-based vehicle use, and digital services that made mobility more flexible and efficient. In terms of design, the decade changed significantly due to the integration of new technologies and the shift in consumption and environmental aspects. Vehicles became more aerodynamic, lighter, and more energy efficient, with material innovations such as carbon fiber reinforced plastics and aluminum increasingly being used. Interiors became more digital and connected, with touchscreens, digital dashboards, voice control, and personalized driver profiles enhanced the driving experience. Comfort, safety, and ease of use merged with new aesthetic concepts that made the progress and modernity of the vehicles visible. At the same time, the trend continued for vehicles to be designed to be not only functional, but also emotionally appealing, in order to strengthen the bond between vehicle and driver. The 2010s were also marked by a growing importance of environmental awareness. Emissions regulations have been tightened around the world, particularly in Europe, China, and North America. CO2 reduction, fuel efficiency, and environmental compatibility became decisive criteria for vehicle development and market acceptance. Manufacturers have had to adapt their strategies to make vehicles lighter, more fuel efficient, and more sustainable, while meeting consumers' rising expectations for performance, comfort, and technology. The combination of ecology, innovation, and economic feasibility was a central challenge that decisively shaped the strategic thinking of the automotive industry. In parallel with these developments, the SUV market continued to grow, but vehicles were increasingly electrified and technologized. SUVs and crossovers have been equipped with modern powertrains, hybrid or electric motors, and advanced safety systems. At the same time, compact city cars and efficient small cars gained in importance, as urban mobility, parking problems, and traffic congestion increased the demand for agile and economical vehicles. The market became highly differentiated. Luxury, performance, efficiency, connectivity, and sustainability were equally demanded, forcing manufacturers to serve a large number of segments at the same time. The sports and luxury vehicle industry also benefited from electronics and new powertrains. Supercars were increasingly equipped with hybrid technology that combined power and efficiency. Luxury vehicles offered high-tech comfort, automated driving functions, personalized interiors, and digital connectivity. These developments led to a symbiosis of technology, performance, and luxury that revolutionized the driving experience and redefined expectations of modern vehicles. The industry proved that progress, sustainability, and exclusivity do not have to contradict each other, but rather be merged with each other. Cultural change was also a decisive aspect of the decade. The car was increasingly perceived as part of a connected lifestyle, less as a pure means of transportation and more as a platform for communication, entertainment, work, and mobility. Electromobility, autonomous systems, and digital networking are fundamentally changing the relationship between people and vehicles. The driver increasingly became a user who could rely on intelligent systems, while the vehicle itself collected information, supported decisions, and made mobility more efficient. These changes have led to a reassessment of what automobility means in the 21st century and the role of the car in an increasingly digitalized world. In summary, the 2010s can be described as a decade of electrification, digitalization, and connectivity. Vehicles have become smarter, greener, and more comfortable. Autonomous systems, connected platforms, and electric drives shaped the entire industry and changed the way people experience and shape mobility. The developments of these years laid the foundation for the mobility of the future, in which efficiency, sustainability, technology, and connectivity play central roles. The 2010s proved that innovation, environmental awareness, and digital transformation are inextricably linked, and that the automotive industry needs to set new standards for mobility in an increasingly connected world.
Chapter 17. The 2020s. The 2020s, electric mobility in the mainstream, autonomous driving, and sustainable mobility. The 2020s mark a historic turning point in automotive history, in which the developments of the last decades became visible to the general public and in people's everyday lives for the first time. While the 2010s had laid the technological foundation for electric mobility, autonomous systems, and digital connectivity, the 2020s began to bring these innovations into the mainstream and fundamentally transform the automotive industry. The car changed from a pure means of transport to an integral part of a sustainable, networked, and digitized society. Electromobility is at the center of this decade. Vehicles with purely electric drive are no longer a niche product for tech-savvy or environmentally conscious customers, but are increasingly becoming the standard. Manufacturers around the world have implemented ambitious electrification strategies, developed new platforms specifically for electric vehicles, and massively expanded production. Major companies such as Volkswagen, Mercedes-Benz, Ford, GM, and Toyota have committed to electrifying their vehicle fleets step by step, while specialist manufacturers such as Tesla, NIO, and Rivian continue to pioneer. The improvement of battery technology is a central driver of this development. Ranges of 400 to 600 kilometers, shorter charging times, and long-lasting batteries make electric cars increasingly attractive to broad sections of the population. Charging infrastructure has been massively expanded. Fast charging stations and intelligent networks ensure that the everyday use of electric cars is practical and reliable. In addition to pure electromobility, sustainability plays a decisive role. Vehicle manufacturers look not only at the operation of the vehicles, but also at the entire production chain from an ecological point of view. Recyclable materials, sustainable batteries, CO2-neutral factories, and resource-saving production methods are becoming increasingly standard. Consumers are paying more attention to the environmental footprint of their vehicles, and governments around the world are enforcing strict CO2 targets, subsidies for electric cars, and driving bans on old combustion engines. This combination of government regulation, technological feasibility, and societal pressure is accelerating the transformation of the automotive industry like never before. Autonomous driving is developing rapidly in parallel with electromobility. Semi-autonomous systems, which were already used in the 2010s, are continuously being improved and are available in more vehicles. Adaptive cruise control, automatic lane changes, emergency brake assistance, and intelligent traffic jam assistance are now standard in modern vehicles. At the same time, sophisticated autonomous vehicles are being tested that have the potential to completely replace the driver. Cities and businesses are experimenting with autonomous taxis, delivery vehicles, and shuttle services to make transportation more efficient, safe, and environmentally friendly. The focus is on ethical, legal, and infrastructural issues. Society must decide how responsibility, liability, and safety are distributed in a world in which vehicles act independently.
The networking of vehicles has become an integral part of mobility. Vehicles communicate not only with the driver, but also with each other, with the environment, and with intelligent traffic systems. Real-time traffic data, digital map updates, cloud-based diagnostics, and personalized services improve safety, efficiency, and comfort. Car sharing, ride-hailing, and fleet management use this networking to make mobility more flexible, economical, and ecologically sustainable. At the same time, new digital ecosystems are emerging in which vehicles not only transport but also function as platforms for entertainment, work, and communication. Design and technology are merging more than ever in this decade. Vehicles will be designed to be more aerodynamic, lighter, and more modular to optimize both range and efficiency. Interiors are becoming digitalized, more minimalist, and more flexible, with screens, voice control, and intelligent sensors revolutionizing the interaction between driver and vehicle. Comfort, safety, and sustainability combine to create a new, holistic design approach. At the same time, vehicles are becoming symbols of technological progress and social awareness. A car is no longer just a status object, but also an expression of ecological responsibility and digital competence. SUVs, sedans, city cars, and sports cars are increasingly being electrified. While SUVs continue to dominate the mass market, compact vehicles, urban mobility solutions, and special vehicles for sharing models are gaining in importance. Consumer acceptance is increasing as electric vehicles can increasingly compete with combustion engines in terms of performance, range, and price. Luxury and sports vehicles are using the decade to redefine performance limits by combining electric motors, hybrid technology, and advanced materials. These developments show that environmental awareness, comfort, and performance can go hand in hand today. Another key aspect of the 2020s is the integration of artificial intelligence and big data. Vehicles continuously collect data on driving behavior, traffic situations, road conditions, and environmental factors. This information is used to improve autonomous driving algorithms, efficiently control traffic, and create personalized driving experiences. At the same time, privacy and security issues are emerging, forcing the industry to develop transparent, secure, and ethical solutions. Vehicles will not only become smarter, but also part of a global infrastructure for mobility, energy, and digital services. The 2020s are also characterized by an increasing networking of the automotive industry, energy supply, and urban planning. Charging infrastructures, power grids, renewable energy, and intelligent transport systems are being coordinated to integrate the growing number of electric vehicles efficiently and sustainably. Cities are developing concepts for emission-free zones, sustainable public transport, and connected mobility solutions. The automotive industry is working more closely than ever with energy companies, technology providers, and municipalities to shape the mobility of the future. In summary, the 2020s are a decade of normalization and mainstreaming of innovations that have been prepared over the past decades. Electromobility, autonomous driving, digital networking, and sustainable mobility are becoming natural components of everyday life. Vehicles are evolving into intelligent, environmentally friendly, and connected systems that go far beyond just getting around. The 2020s show that the automotive industry is not only being transformed technologically, but also needs to be repositioned socially and ecologically. Innovation, sustainability, and connectivity are no longer optional trends, but central requirements for mobility in the 21st century. This decade will have a lasting impact on how people drive, think, and experience mobility.
Chapter 18: Future Perspectives, Hydrogen, AI-Driven Vehicles, and Global Mobility Concepts. The automotive industry is at an inflection point in the late 2020s and early 2030s, setting the course for decades to come. While the 2010s and 2020s have driven the electrification, digitalization, and connectivity of vehicles, the present and immediate future open up entirely new possibilities. The focus is on alternative drive systems such as hydrogen technology, artificially intelligent vehicles, global mobility solutions, and the integration of automobility into sustainable urban structures.
These developments show that the car has become not just a means of transport, but a complex system that combines technology, the environment, and society. Hydrogen propulsion systems are attracting increasing attention. While battery-powered electric cars dominate the market, hydrogen fuel cell vehicles offer advantages in terms of range, fast refueling, and energy efficiency for large-volume vehicles such as trucks, buses, or ships. Companies such as Toyota, Hyundai, and Nikola are working on vehicles that meet the challenges of infrastructure, energy generation, and storage of hydrogen. In combination with renewable energies, hydrogen can enable emission-free mobility and further reduce dependence on fossil fuels. At the same time, industry is faced with the challenge of making hydrogen production, transport, and storage economically and ecologically sensible. Political funding, international cooperation, and technological innovations will be decisive in determining whether hydrogen can be used on a large scale as an alternative fuel. At the same time, artificial intelligence and machine learning are fundamentally changing the way vehicles work. Vehicles of the future will not only be driver-assisted, but increasingly self-learning and forward-looking. AI systems continuously analyze traffic patterns, weather conditions, road conditions, and the behavior of other road users to make driving safer, more efficient, and more comfortable. Autonomous vehicles are evolving from experimental prototypes to near-series products that can independently master not only individual tasks, but also complex traffic flows. AI enables vehicles to react to unforeseen situations in real time, minimizing risks and at the same time reducing environmental impact through optimized driving strategies. This means that the role of humans is increasingly shifting from an active driver to a monitoring user who supports decisions but no longer has to control all the details themselves. Global mobility concepts are also becoming increasingly relevant. In densely populated cities where space, air quality, and traffic volumes are problematic, new models of transport are emerging that go beyond individual cars. Car sharing, autonomous shuttle services, multimodal transport services, and networked public transport systems create seamless, efficient mobility. Vehicles are becoming part of a larger ecosystem that integrates data, energy, and infrastructure to make transportation more sustainable and accessible. The networking of means of transport, communication technologies, and urban planning play a central role in this. Cities such as Singapore, Copenhagen, or Los Angeles are serving as pioneers by testing concepts that combine private cars, public transport, and alternative means of transport. The design of vehicles is adapting to these changes, and vehicles of the future will be lighter, more modular, and more digital than ever before. Interiors are designed to be more flexible as active driving is no longer necessary in many situations and vehicles are used as mobile work or leisure spaces. Digitalization, connected displays, and adaptive user interfaces enable personalized experiences while sustainable materials, recyclable plastics, and energy-efficient production processes meet ecological requirements. Aesthetics, comfort, and environmental awareness merge into a new understanding of design that redefines consumer expectations of the car in the 21st century. At the same time, social changes are evident in how people perceive mobility. Vehicles are no longer just status symbols, but means of integration into an efficient, sustainable, and networked life. The integration of vehicles into smart cities also means that transport infrastructure and energy supply are merging. Electric vehicle charging stations, hydrogen refueling stations, and charging parks are increasingly becoming part of the urban landscape. Transport systems communicate with vehicles to avoid congestion, optimize energy consumption, and reduce emissions. Sensing, digital maps, and real-time data make it possible to make mobility efficient while at the same time creating new business models ranging from vehicle manufacturing to the provision of mobility services. Energy, data, and transport will become interconnected systems that form the basis for the cities of the future. Another decisive factor is sustainability. Automotive manufacturers and technology companies are not only pursuing short-term goals such as reducing CO2 emissions, but long-term strategies for the circular economy. Batteries are recycled, vehicles are designed to be modular, raw materials are used efficiently, and production processes are optimized for minimal environmental impact. Consumers are increasingly looking at the entire life cycle of a vehicle, from manufacturing to operation and recycling. Sustainability is no longer a trend, but an integral part of the automotive industry, shaping design, technology, and market strategy. Sports and luxury vehicles are also benefiting from these developments. High-performance vehicles combine electric motors, hybrid powertrains, and AI-driven systems to maximize both performance and efficiency. The technological transformation expands the possibilities for performance, driving dynamics, and safety without having to neglect environmental aspects. This shows that innovation, luxury, and sustainability are not a contradiction, but can merge into a new, holistic vehicle philosophy. Finally, society's perspectives on mobility are also changing. The car is no longer seen exclusively as an object of ownership, but as part of a mobility system that combines efficiency, sustainability, and digital networking. People use vehicles not only for transportation, but as flexible, smart spaces that enable work, leisure, and social interaction. This is changing the way cities are designed, how transport planning works, and how individual mobility decisions are made. The car is no longer isolated, but embedded in a global, sustainable, and digital mobility system. In summary, the developments of the late 2020s and the coming decades show that automotive history is at a crucial turning point. Hydrogen technology, AI-controlled vehicles, networked mobility concepts, and sustainable production methods are fundamentally changing the industry. Vehicles are becoming smarter, more efficient, and more ecologically compatible. At the same time, they are changing the way people perceive, experience, and shape mobility. The future of automobility is no longer just technical progress, but a combination of technology, ecology, society, and urban planning. In this new era, the car is becoming an integral part of a globally connected, sustainable, and digital world, where mobility is not just movement, but about making everyday life smart, conscious, and environmentally friendly.
Chapter 19: Global Industry Shifts, Automotive Markets in Asia, Europe, and North America. The automotive industry of the 21st century is experiencing an unprecedented phase of global reorganization in which markets, technologies, and economic power are shifting and redistributing. The leading automotive nations of Europe and North America are increasingly competing with Asia, which is gaining in importance due to technological innovations, flexible production structures, and huge consumer markets. In this decade, it becomes clear that the future of mobility must no longer be thought of regionally, but globally, as economic, technological, and ecological dynamics have a transnational effect. Asia, especially China, plays a central role in this. Within a few decades, China has developed from a demand market to a leading production location and innovation center. Manufacturers such as BYD, NIO, XPeng, and Geely are betting on electric vehicles, digital connectivity, and autonomous systems, competing directly with traditional American and European brands. At the same time, the Chinese government is pursuing a consistent strategy to strengthen the domestic automotive industry. Subsidies for electric vehicles, promotion of battery technology, and the development of a comprehensive charging infrastructure have made China a global pioneer in the field of electric mobility. In addition, the Chinese middle class has grown as a consumer of mobility, and the demand for modern, environmentally friendly vehicles is growing exponentially. China is thus not only a production location, but also a driver of innovation and a global test field for new mobility concepts. In Europe, the automotive industry is historically strongly anchored and continues to be dominated by established brands such as Volkswagen, BMW, Mercedes-Benz, Renault, and Peugeot. However, European manufacturers are under considerable pressure to accelerate the transformation towards electric mobility, autonomous vehicles, and sustainable production. European countries are enforcing strict CO2 targets and environmental regulations that force car manufacturers to redefine their strategies.
At the same time, the European market offers high purchasing power, technological expertise, and strong infrastructure for research and development. Europe remains a hub for design, engineering, and premium vehicles, but competition with Asia and North America requires adaptation, collaborations, and rapid innovation cycles to ensure global competitiveness. North America, led by the U.S., is a traditional hub of the automotive industry, characterized by innovation and mass production. Companies such as General Motors, Ford, and Tesla are shaping the industrial landscape and technological development. Tesla, as a pioneer of electric mobility, has shown that disruptive change is possible, while traditional manufacturers are adapting their strategies to remain competitive. North America benefits from a large domestic market, a flexible economy, and a culture of technological openness. At the same time, manufacturers are faced with the challenge of balancing global supply chains, sustainable production, and regulatory requirements. The U.S. is also using its technological leadership in areas such as artificial intelligence, autonomous driving, and battery research to shape the automotive industry of the future. A key factor in the global shifts is the supply chain strategy. While Asia has significant capacity to produce batteries, semiconductors, and components, European and North American manufacturers need to adapt their production and sourcing strategies to reduce dependencies and ensure supply. At the same time, new partnerships and joint ventures are emerging across continents. Companies work together to share technology, diversify production sites, and secure access to international markets. These strategic alliances influence not only the economic distribution of power, but also the speed at which innovations become globally available. Technological differentiation plays a crucial role in positioning in global markets. While Europe focuses on premium vehicles, quality, and sustainability, North American manufacturers score points with scalability, performance, and disruptive business models. Asia, on the other hand, combines cost efficiency with technological innovation, especially in the field of electric vehicles and digital connectivity. These different strengths lead to complex global dynamics in which manufacturers have to adjust not only their products, but also their production and distribution concepts. The relocation of markets also has an impact on the structure of jobs. Production, research, and development are increasingly shifting to Asia, while traditional production sites in Europe and North America are being rationalized or modernized in some cases. At the same time, new job profiles in the fields of software development, data analysis, artificial intelligence, and sustainable production are emerging to accompany the change. The automotive industry is evolving from classic mechanical engineering to a highly networked technology and service sector. Global trade flows are also changing. Export-oriented countries benefit from new markets, while local markets are more influenced by international brands. Trade agreements, customs regulations, and geopolitical tensions are influencing production and supply chains, forcing companies to act flexibly and strategically. The ability to adapt to global economic changes is increasingly becoming a key competitive factor. The importance of research and development cannot be overestimated in this context. Companies that invest early in battery technology, autonomous systems, artificial intelligence, and sustainable materials secure a decisive advantage. Innovations are increasingly not being developed in isolation, but in global networks that exchange knowledge and technologies across national borders. This not only enables faster progress, but also a broader implementation of technological solutions. After all, social trends are shaping the global shift in automotive markets. In Asia, Europe, and North America, awareness of environmental issues, urban mobility, and digital connectivity is growing. Consumers demand vehicles that are efficient, sustainable, and intelligent. Automotive manufacturers must respond to these changing requirements in order to remain relevant. At the same time, new business models such as car sharing, fleet management, and digital mobility services are emerging that challenge traditional vehicle ownership. The automotive industry is thus not only undergoing technological change, but also undergoing a far-reaching process of social transformation. In summary, Chapter 19 shows that the global shifts in the automotive industry are complex, dynamic, and interdependent. Asia, Europe, and North America are developing different strengths, responding to regional demands while competing on a global scale. Technological innovation, strategic partnerships, and adaptability are critical to succeed in this new international environment. The automotive markets are shifting not only geographically, but also functionally, technologically, and socially. The future of mobility is global, connected, and dynamic, and the coming decades will determine which regions and companies will take the leading role in an increasingly digitized, sustainable, and intelligent automotive world.
Chapter 20: The Car of the Future: Visions, Challenges, and Social Implications. The car of the future no longer stands only for individual mobility, but for a complex interplay of technology, environmental awareness, society, and urban planning. The developments of the past decades have transformed the vehicle from a mechanical means of transport to an intelligent, networked, and increasingly autonomous system. Visions that were considered futuristic just a few years ago are now within reach, and the automotive industry faces the challenge of translating these visions into practical, safe, and sustainable solutions. The future of the car is therefore not just a question of engine technology, design, or performance, but of the way people experience, use, and integrate mobility into their everyday lives. Autonomous vehicles are the central element of this vision of the future. Artificial intelligence and machine learning enable vehicles to make decisions on their own, analyze traffic patterns, and detect hazards in real time. This development is changing not only the driving experience, but also the role of humans in the vehicle. The driver is increasingly becoming an observer and decision-maker in critical situations, while routine tasks such as lane keeping, distance maintenance, or speed adjustment are fully automated. Autonomy promises not only more comfort, but also a drastic reduction in accidents, as human error, which was previously the main cause of road accidents, is minimized. At the same time, this technology raises ethical and legal questions, such as who is responsible in the event of an accident, or how the decision-making algorithms weigh moral dilemmas. Electromobility forms the backbone of sustainable visions of the future. Battery-powered vehicles reduce dependence on fossil fuels and help reduce CO2 emissions. Advances in battery technology, such as solid-state batteries or hybrid energy storage solutions, promise longer ranges, shorter charging times, and longer life cycles. At the same time, companies are researching hydrogen propulsion and synthetic fuels, which are particularly relevant for heavy vehicles, ships, and aircraft. However, the choice of drive is not only a technological issue, but also a social and infrastructural challenge. Charging and refueling infrastructure must be available nationwide. Power grids must be stabilized, and energy sources must be provided sustainably. The design of future vehicles is based on multifunctional needs. Interiors can be used flexibly, as active driving is no longer necessary in many situations. Vehicles are no longer only used for locomotion, but also as a work, communication, or leisure space. Modular concepts make it possible to customize vehicles, while sustainable materials and recyclable components combine ecological responsibility with comfort and aesthetics. Exterior designs integrate aerodynamics, efficiency, and digital sensing, making cars technological and cultural symbols of a new era of mobility. Integration into urban environments poses further challenges. Cities must adapt infrastructure, traffic planning, and energy supply to the needs of autonomous, electric, and connected vehicles. Smart roads, digital traffic control systems, and charging stations are just a few elements of a complex ecosystem that makes mobility efficient, safe, and sustainable. The future of the car is therefore not just a question of engine technology, design, or performance, but of the way people experience, use, and integrate mobility into their everyday lives. The social implications of the automobility of the future are profound. Mobility is increasingly understood as a service, not as property. People adapt their use to demand, environmental awareness, and convenience. The social role of the car is changing.
Traditional status symbols are receding into the background, while functionality, efficiency, and connectivity are coming to the fore. At the same time, technological advances raise new ethical, legal, and data protection questions. Who owns the data that vehicles generate? How are decisions made by autonomous systems transparent and comprehensible? How do you prevent social inequalities in the use of sophisticated mobility services? After all, the vision of the car of the future shows that technology and society are closely intertwined. Innovations are not an end in themselves, but a means to make mobility more efficient, sustainable, and safer. The car is becoming a hub for urban, global, and digital networking. The challenge is to balance technical possibilities, economic interests, and social needs. The successful implementation of this vision will determine how mobility will be shaped in the 21st century, what role the car will play in society, and how cities, regions, and nations will be networked with each other. The future of automobility is not a linear development, but a dynamic process that is shaped by technology, the market, politics, and society at the same time. Hydrogen, electromobility, autonomous systems, digital networking, urban integration, and sustainable production are the building blocks of a new era that transforms the car from a simple means of transport to a highly complex, intelligent, socially relevant, and ecologically responsible system. This vision merges progress and responsibility, innovation and sustainability, technology and the reality of life. The car of the future is not just a question of powertrain, but a reflection of the values, priorities, and opportunities of society itself. The challenge is that this future must be realistic and visionary at the same time. Technological feasibility, economic viability, social acceptance, and environmental responsibility must go hand in hand. Only if these elements are integrated in a balanced way can the car of the future become not only a symbol of progress, but also of sustainable, intelligent, and humane mobility. The coming decades will show how fast and how far this transformation can progress, and what role the car will play in a globally connected, digital, and ecologically conscious world. The history of the automobile does not end today, but continues in a future that is at once tangible, challenging, and full of opportunities.